Welcome to the Top 5 Auto Advice. First, we'll review the fundamentals of how an engine operates and some basic engine terminology before we examine some technologies Toyota uses to maximize engine performance and economy and reduce emissions. We'll now look at the fundamental parts of an engine. The engine's main parts are the engine block and cylinder head. The engine's internal parts include the cylinders. An internal combustion engine requires fuel and air to operate. The more effectively an engine breathes, the more effectively it will produce power. The connecting rods of the crankshaft spark plugs and pistons the intake and exhaust valves on fuel injectors. The four-stroke engine produces power through the use of camshafts and a timing chain or belt. The intake stroke occurs as the piston moves on its first downward stroke, allowing a mixture of air and fuel to fill the combustion chamber. The compression stroke occurs as the piston moves on its second upward stroke, compressing the air-fuel mixture, which will cause it to burn more vigorously than if it were uncompressed. Finally, the spark plug ignites the air-fuel mixture. The power stroke is what we refer to as. The exhaust stroke occurs on the fourth stroke. The exhaust valve opens as the piston begins its second upward stroke and the burned air fuel. Through the exhaust valves, mixture is ejected from the combustion chamber. Customers might ask you to define the engine's compression ratio and displacement. In this example, the compression ratio is 10 to 1. Higher compression ratios produce more power. Compression ratio is the ratio between the total volume of a combustion chamber and cylinder when the piston is at the bottom of its stroke and when the piston is at the top of its stroke. However, demand more octane higher fuel than engines with lower compression ratios. Engine displacement is a term used to describe an engine's internal size. It is calculated by multiplying the length of the piston stroke by the number of cylinders, and is typically expressed in liters or cubic centimeters. For instance, a four-cylinder engine with a displacement of 2.4 liters would have a total displacement of 2.4 liters if all four cylinders were added together. Different engines have different numbers of valves. Some older engines have 2 intake valves and 1 exhaust valve, while others typically have 1 intake and 1 exhaust valve. The majority of powerful engines utilize 2 exhaust and 2 intake valves. The camshaft is responsible for opening and closing the valves in some engines. If the camshaft is mounted above the valves, the engine is known as a single overhead camshaft SOHC engine. When the intake and exhaust valves are operated by separate camshafts mounted above the valves, the engine is known as a dual overhead camshaft DOHC. DOHC, or double overhead camshafts, is the name of this design. There are double overhead camshafts in every Toyota engine. Most four-cylinder engines have an inline design with more than 4 cylinders, including all Toyota four-cylinder engines. How the cylinders typically arranged in AV configuration. Let's examine the technologies Toyota uses in its engines to improve power output, fuel efficiency, and emissions control. All of Toyota's 6- and 8-cylinder engines are V-type engines. An engine will produce power more effectively the more effectively it can breathe. The acoustic control induction system and other features found in Toyota engines are intended to improve the engine's ability to breathe. In order to maximize air flow into the engine and to provide more usable power throughout the entire RPM range at low speeds, the intake manifold's runners automatically vary in length. To generate sufficient low-end power and torque, AC directs intake air flow through a long intake runner. Imagine doing this while inhaling deeply as you lift something heavy while driving at high engine speeds. In order to produce more horsepower, AC directs the air through a short intake runner. Some manufacturers compare it to taking rapid, shallow breaths while operating. Use a single SOHC or overhead engine, since the power of an engine is determined by how much air and fuel can be burned in a specific amount of time. Double overhead cam, or DOHC engines, which are standard in all Toyota vehicles, allow for the best placement of the valves. Benefits of a DOHC design include enhanced power output, fuel economy, and emissions control. Toyota uses 4 valves per cylinder rather than 2 or 3, which enhances the engine's performance in the intake and exhaust systems. A 6-cylinder engine with 4 valves per cylinder and variable valve timing with intelligence, or VD, would be a 24-valve engine. A computerized system changes the intake valve timing to optimize the engine's breathing depending on the conditions. Without VD, valve timing is fixed regardless of how fast the engine is turning. So an engine that performs well at high speeds won't perform as well at low speed and vice versa. With VD, intake valve timing is constantly adjusted, enabling the engine to produce horsepower and torque across a broad RPM range or power band. This gives an even wider range of valve control in combination with one another. Because the intake and exhaust valves can be controlled separately by double overhead camshafts, the power and torque output and fuel efficiency are improved across the entire power band of the vehicle. Similar to a CIS, a dual-path exhaust system maximizes exhaust flow out of the engine. A second path or chamber opens in the exhaust system at higher RPM to help evacuate the higher volume of exhaust, leading to better breathing with less back pressure. Thanks for watching.